Good morning, everyone. This is Rahul Badam from CSC Regular. Today, I'm here to explain three problems on nodal analysis. Before explaining what nodal analysis is, let me tell you what a node is. It is the point through which a circuit element is connected to the circuit, or in simple terms, it can be referred to as a junction point in the circuit. For example, in this circuit, point A is a node. Now, what is a nodal analysis? It is a method of determining the voltage, or also known as the potential difference between nodes in the circuit in terms of the branch currents. It is an application of KCL. Now, let me brief you about KCL, which is the base to solve all the problems in nodal analysis. KCL states that the algebraic sum of all the currents entering and exiting a node is equal to 0. That is, the entering currents is equal to the exiting currents. Now, let's get to the problems. Okay, before problems, let me explain you the steps involved in nodal analysis. Step 1. Identify all independent nodes wherever the current branches out and select a reference node. Now, step 2 is to write the nodal equation using KCL for all the nodes except the reference node because the reference node's potential is considered to be 0 in the circuit. Now, the step 3 is to solve the nodal equations and find the required voltages and branch currents. Are you ready for the questions? Let's get to the first question. It says, using nodal analysis, determine the nodal voltages for the circuit shown. Now, this circuit contains a 2 ampere source and a 20-volt voltage source with 4 resistors of different resistances. Now, let's assume this whole point to be the reference node whose potential is considered to be 0. Let this point be V1 and this point be V2. Now, in nodal analysis, the node at which the KCL is applied is considered to be of highest potential. Hence, for nodal analysis at V1, V1 is greater than V2, and at V2, V1 is less than V2. Now, since current flows from higher potential to lower potential, the outgoing current is taken as positive during the nodal analysis, and the incoming current is taken as negative. Now, here, since the presence of 2 ampere current source, this current flows into node 1, and hence 2 ampere is taken to be negative or on the left hand side. Now, applying KCL at node 1, we get 2 is equal to V1 by 5 plus V1 minus V2 by 6. V1 minus V2 because it is considered to be of highest potential. Now, simplifying, we get 0.367 V1 minus 0.167 V2 is equal to 2. In a similar fashion, we apply nodal analysis at node 2, which says V2 minus V1 by 6 plus V2 by 3 plus V2 minus 20 by 10. Now, here we are doing this because it is V by R, which is I, that is the basic application of KCL and Ohm's law. Now, on solving this equation, we get minus 0.167 V1 plus 0.597 V2 is equal to 2. Now, on solving both these equations, we get V1 as 7.991 and V2 as 5.585 volts, respectively. Now, let's get to the second question. It says, for the given circuit, determine the currents in each branch. Now, there are 1, 2, 3, and 4 branches and 4 different resistors with a 10 ampere current source and a 5-volt voltage source. Now, let's assume this to be V1 and this as V2. Applying nodal analysis at V1 using KCL, we get 10 is equal to V1 by 5 plus V1 minus V2 by 4. 10 is on the left hand side because it is incoming current, which, as already mentioned, is taken to be negative. That is, 9 by 20 V1 minus V2 by 4 is 10. Now, the same should be applied at V2, which implies V2 minus V1 by 4 plus V2 by 10 plus V5 minus 5 by 2 is 0. That is, 17 by 20 V2 minus V1 by 4 is equal to 5 by 2. Now, solving equations 1 and 2, we get V1 potential as 11.33 volts and V2 as 28.5 volts. Now, Ohm's law states that V is equal to IR or I is equal to V by R. Now, applying Ohm's law to the different branches, and since this is a reference voltage, the potential difference across this 5 ohm resistor is V1 and across 10 ohm resistor is V2. Across 4 ohm resistor, it is V1 minus V2, and across this 2 ohm resistor, it is V2 minus 5. Now, applying the Ohm's law at respective branches, we get the current values as I5 is 5.7 amps, I10 is 1.133 amperes, I4 as 4.2925, and I2 as 3.165 ampere respectively. Now let's get to the last question. It says, for the circuit, find the voltage across the 6 ohm resistor by using nodal analysis. Now 6 ohm resistor voltage is Vx and this is V1 and V2. We have a 4 ampere source going down and a dependent source present which is 6 times the Vx, that is 6 times the potential across the 6 ohm resistor. Now there is a source of 4 volt and even 3 resistors of 5, 4 and 3 ohm respectively other than 6 ohm resistor. Now applying KCL at V1, we get 4, that is the outgoing current which is positive, plus V1 by 5 plus V1 plus 4 minus V2 by 6 plus V1 minus V2 by 4, 0. On simplifying, we get 37 V1 minus 25 V2 is minus 280. Now applying the same at V2, we get V2 minus V1 minus 4 is equal by 6 plus V2 minus V1 by 4 minus 6 Vx, this dependent source which is on this 6 ohm voltage, plus V2 by 3 is equal to 0. Substituting these equations, we get minus 77 V1 plus 81 V2 is equal to 296. And on further simplification, we get V1 as minus 14.25 and V2 as minus 9.89 volts. Now, Vx can be determined as V1 plus 4 minus V2. That is minus 14.25 plus 4 plus 9.89, which is minus 0.30 volts. I hope you have understood the problems and even the concept well. Thank you.